after the German physicist Gustav Magnus, who was the first person to venture in a rigorous investigation into the physics entailed. Magnus' effect is an air pressure differential that causes an object to essentially lift in the air by generation of a sidewise force on a spinning, cylindrical or spherical solid immersed in a fluid, liquid or gas, when there is relative motion between the spinning body and the fluid. A cluster of lines run in the same direction as one side of the swirling cylinder, and in this case, these are the lines below the cylinder, whereas the cylinder's other side moves in the opposite direction of the wind, colliding into its drag lines head-on in its curves. The swift and higher lines moving in the same direction create an area of low pressure, while the turbulence on the other side builds an area of high pressure. It is this pressure difference that pushes the cylinder in the direction of the spin, or more formally, in the direction of the pressure differential, from high pressure to low pressure. This gradual curl can be shown to be encouraged by a force. This is called the Magnus force. The experiment we've chosen is a dihedral glider. Wing dihedral is the upward angle of an aircraft's wing, from the wing root to the wing tip. The amount of dihedral determines the amount of inherent stability along the roll axis. This is essential for this experiment, since the air can very quickly take the glider to a different direction. This glider uses the Magnus effect in order to keep floating by rotating on its own axis to create a lift force. It is important to realize that the lift force generated by this effect is not very reliable. Eventually, the material will end up falling down due to the weight of the material.